Okay, right on. So only one problem I will do. Okay, and 2, 3 I will give as homework. All right. So take down for the given Bode plot. For the given Bode plot, determine a1, a2, omega 1 and omega 2. Also find the transfer function. Also find the transfer function. So the given Bode diagram is something like this. Okay. And this is minus 40 decibel per decade. And here you have minus 20 decibel per decade. And this is once again minus 40 decibel per decade. Okay. And you have been given with, this is your y-axis, the decibel axis. This is your x-axis, which is nothing but your log omega axis. All right. And something like A1 you need to determine. And the frequency at which A1 needs to be determined is 10 radian per second. And this is 40 radian per second. This point corresponds to 40 radian per second. And this is omega 1. Sorry, that's not omega 1. That's 1000 radian. That's 1000 radians per second. And somewhere here, some magnitude they have taken, and that magnitude found to be minus 20 decibel. And the corresponding frequency you need to determine. So that's omega 1. All right. And some magnitude A2. Minus 40 decibel. At some frequency omega 2. This is A2. I'll send this screenshot in the class group. Okay, so that's the problem. So you can refer. All right, so you have to determine A1. So A1 needs to be determined at omega equal to 10 radian per second, and A2 needs to be determined. So A2 needs to be determined at omega equal to 1000 radian per second. Okay, and then you have to find what is omega 1 and at omega 2. So these things you need to determine from the Bode plot. Okay, so that's the first task, finding the unknowns, and the second task is to determine the transfer function. All right. So to determine the transfer function, okay, let me take a part of second part in the beginning. All right. So you know that poles and zeros basically contributes different slopes. Normally poles contributes negative slope and zeros contribute positive slope. All right. Now what you have to see is, okay, you have to look at the first slope. Okay, now you can see that your Bode diagram is starting with a slope of minus 40 decibel per decade. That means to say you have to have some pole over there, right? Because negative slope is given by pole. And if you see, I mean, if extend this particular straight line, somewhere it is going to touch the y-axis, right? Somewhere it is going to touch the y-axis. So the starting point you need to determine. That can be done sometime later. Okay, fine. Now you tell me which factor gives a slope of minus 40 decibel per decade. Can anyone tell me? Pole, right? So basically you have to have double pole at origin. Double pole at origin. Now, why it is double pole? Why not it is second order pole? Why not a second order pole? Why it should be a double pole at origin? So you can observe that at omega is equal to 0, the Bode diagram is having some magnitude, right? So that means to say you have to have a pole at origin. But the starting slope is minus 40, hence you should have double pole, because single pole will give you minus 20 decibel per decade slope. So your first factor going to be double pole at origin with some K value. Okay, so this particular intercept with y-axis is going to give you a K value. All right. So first factor is double pole at origin. Okay. Now you can see that at omega equal to 40 radian per second, the slope is changing to minus 20 decibel per decade. Your previous slope is minus 40 and the current slope is minus 20 decibel per decade. So to get minus 20 decibel per decade, how much you have to add? You have to add plus 20 decibel per decade. Now, what is this plus 20 decibel per decade? It has to be a 0, right? So 0 contributes positive slope. So you can say that at omega equal to 40, you have first order 0. You have a first order 0. All right. So the slope continues till say point this point, right? Omega equal to 1000. So at omega equal to 1000, the slope is getting changed to once again minus 40 decibel per decade. So to get minus 40 decibel per decade, how much slope you need to add? You need to add minus 20, right? Because previous slope is minus 20. And if you add further minus 20, you will get the next slope as minus 40 decibel per decade. That means to say there is first order pole. So there is a first order pole. So this is how we identify the factors of the transfer function. So basically this particular transfer function, okay, g of s into h of s will have some k value, and that k value is determined by this particular intercept. And what do we have? We have a double pole at origin, so you will have some s square term, and then you have first order 0, so that is 1 plus st1 you will have, and you will have a first order pole. So again in the denominator you will have 1 plus st2. t1 and t2 are the time constants of the circuit. So this should be the transfer function of this particular Bode diagram. Alright, so that we need to find out sometime later. Alright. Any doubts in this, you just let me know. No doubts? So that's the first part of the problem. Now let me erase all these lines. Now, in order to determine A1, A2, omega 1, omega 2, what we can do is let us first mark, or let us split this Bode diagram into different lines. So I have one straight line here. So let me call this line as line AB, right? So slope minus 40 decibel per decade is being represented with a line AB, all right? And then I have a slope of minus 20 decibel per decade. That means to say it is a different line. So let us take that particular line as line BC. Okay. And you have the third slope whose value is minus 40 decibel per decade. So let's take that particular line as CD. Okay. So what we have done is we have splitted our Bode diagram into different lines. Line AB, line BC, line CD. So this is your first step. So first step is to mark different lines. Second step is to handle these lines individually. So let's start with the first line. So first let us write line AB. Right, it's a straight line. So let us write an equation for straight line. So equation for straight line is given as y is equal to mx plus c. All right. Now, since we have three lines to distinguish this constant, what we can do is we can take this constant as y is equal to mx plus c1. All right. Once you are done with this, you can proceed with the second step. So y is equal to, now we are talking about line AB. Now what is the slope which you are observing at line AB? So line AB is having a slope of minus 40 decibel per decade. So m value is minus 40. Right, m value is minus 40. Then x, what is x here? X is not a linear frequency. In Bode plot, you are kind of taking a logarithmic scale, right? So x going to be log omega, right? So in place of x, you write log omega, and in place of m, you write the corresponding slope, which is minus 40 plus c1. Okay, so this c1 is basically this whatever I have written right here with a question mark. That should be the constant of this particular straight line. Okay, so if you don't have any factors at origin, it could be a pole or it could be a zero, you would have got c is equal to 0. Okay, it depends. So for this particular problem, you have some intercept with y-axis. Okay, once you are done with the equation of the straight line, what we have to do is we have to just substitute different points in this particular line. So we have some information at point B, right? So let's write at point B. At point B, what information do we have? The magnitude is 0 because this is 0 dB. So at point B, magnitude is 0, right? So y is equal to 0. So let us substitute. Okay, now at point B, what is the frequency value? Frequency value is 40. Magnitude is 0 dB and omega is 40. So let's substitute. So, okay, so substitute this in equation 1. Let's say this is your equation 1. So magnitude is 0. So LHS is 0. So 0 is equal to minus 40 log omega. What is omega? Omega is 40 plus C1, or C1 is equal to plus 40 log 40. So C1 is equal to, put it in your calculator. Let us see what you get. So 40 log 40 is 64.08 dB. So this simply tells that your magnitude plot is starting with a magnitude of 64.08. So basically your Bode plot intercepts with y-axis at 64.08 dB. Now this 64.08 dB is due to the contribution of K. So in order to find K value, what you can do is you can use this formula. In decimal system, 20 log to the base 10, K is equal to C1. And what is C1? C1 is 64.08 dB, or log to the base 10, K is equal to 64.08 divided by 20, or K is equal to 10 to the power, right? So when you take anti-log, it is 10 to the power x, so 10 to the power 64.08 divided by 20. Put it in your calculator, you will get K as 1600. 1600. So we have already determined the K value, which is 1600. All right. Fine. So keep this answer aside. We need it because we need to find some unknown A1 in line AB, right? I'll erase this. Okay. Then you can also see that at omega equal to 10, the magnitude is found to be A1. So you can write at omega is equal to 10, y is equal to A1. So substitute this in equation 1. So what is y? Y is A1, which is equal to minus, slope is 40, right? Minus 40 log omega. So what is omega? Omega is 10 plus C1, right? So C1, we know the answer. What is C1? C1 is 64.08. 64.08. So you have to just substitute and get the value of A1 here. So minus 40 log 10 plus 64.08. So that will give you A1 as 24.08. Okay, please check these answers. Okay, whether you are getting the same answers or not. Feel free to interrupt me in case if you have any doubts. Okay, all right. So we have found basically A1. That's done. So we are done with line A. All right. Now let us go to the different line. Okay. Let's go to the second line, that is line BC. Let us write the equation for line BC. So general form is y is equal to mx plus c2. Why c2? Because it's a different line, so different line will have different constant. So let's take that constant as c2. Let us determine what is c2. Okay, now what do we have in line BC? So we have y is equal to slope as minus 20 and x as log omega, right? Logarithmic scale plus c2. Right, so this is the general equation for line BC. Now what you have to do is you have to just observe line BC and you have to substitute different point values there. All right. So at B, okay, at B, omega is 40. Omega is 40 and y is 0. Y is 0. So let us substitute. So LHS is 0 minus 20 log 40 plus C2, or C2 is equal to 20 log 40. Remember one thing, the logarithmic base is 10, okay, because there are two logarithms, natural logarithm or ln, or logarithm base 10. Okay, so this is log 10, all right. So 20 log 40 you are supposed to find out. So how much do we get? 20 log 40. We get C2 as 32.04. So we get C2 as 32.04 decibels. Okay. Keep it in a box. We need C2 for finding out something else, right? Right. So in line BC, we have one unknown omega 1, right? So we need to find what is omega 1. That can be found now. So you can write at omega equal to omega 1. What is the magnitude? Magnitude is minus 20. So y is equal to minus 20 decimal. Okay. So let's substitute. So LHS is minus 20. So you can write minus 20 is equal to m is minus 20 log omega, which is unknown. So let's take it as omega 1 plus C2, right? We have found the value for C2, that is 32.04. So you can take the value. So it is basically minus 20 minus 32.04 is equal to minus 20 log omega 1, or this is minus 52.04 divided by minus 20. I'm taking 20 on LHS log omega 1, or omega 1 is equal to antilog, right? 10 to the power, basically minus by minus you get a positive ratio. So it is 52.04 divided by 20. Of course, 10 raised it is. So find out what is the value. 10 to the power 52.04 divided by 20 will give you omega 1 something like 399.94. So approximately you can write 400 radian per second. So you have also found omega 1. All right. And what else you need to find? A2, right? A2, is it falling in line BC? Yeah, it is falling in line BC. So you can also determine A2. Okay. So yeah. Let's determine A2 step by step. Okay, step by step you have to go. It's something like waterfall. All right, so you can write at omega is equal to 1000. At omega is equal to 1000. What is your y value? Y value is A2. So y is equal to A2. All right. So therefore, you can write down y, which is A2, is equal to m is the slope minus 20 log omega, right? What is the value of omega? Omega is 1000 plus C2. How much did we get C2 as? 32.04. 32.04. So A2 is equal to, you can just find out, minus 20 log 100, minus 20 log 1000 plus 32.04. So that is minus 27.96. So your magnitude A2 is minus 27.96 decibel. Makes sense, right? You are supposed to get negative because A2 is found below the log omega axis. So that's your A2. So you have found A2 as well. Okay. Now finally you are left with omega 2, which is falling in basically line CD. So you need to take up line CD. Okay. So now you go for line CD. Line CD. So line CD, let us write the equation. Y is equal to mx plus C3. Why C3? Because it's a third line. So different intercept constant it is going to have, right? So y is equal to, what is m for line CD? Minus 40. X is log omega plus C3. All right, so let us try to find out what is the value of C3. So you can say at omega equal to 1000, at omega equal to 1000, y is equal to A2. And what is A2? A2 we have determined from the previous step, right? That is minus 27.96. So that is minus 27.96 decimal. So let us write down. So y is minus 27.96 is equal to minus 40 log omega. So omega is 1000. Okay. The variation is logarithmic. So x-axis is omega because we express radian per second, right? Plus C3. So basically C3 is minus 27.96 plus 40 log 1000. Okay, so that is your C3. So you will get C3 as 92.04. Decimal. So that is your C3 value. Once C3 is determined, you can find out the last unknown omega 2. Okay. So yeah, so they have given us one information that at omega 2 the gain is minus 40 decibel. So you can write at omega 2 y is minus 40 decibel, right? So let us substitute. So we have y value, right? Y value is minus 40. So minus 40 on LHS, and on RHS the slope is minus 40 and log omega. What is that omega value? Omega 2. And plus the intercept value. So intercept value is 92.04. Okay, so you can take something like minus 40, take this on LHS, minus 92.04 is equal to minus 40 log omega, or omega is equal to anti-log of, that is 10 to the power, this is minus 40 minus 92 minus 132.04 divided by 40. So basically you will get a positive ratio and find out what is omega. So omega, you will get it something like 2000 radian per second. It is 1,999 or approximately 2000 radian per second. Okay. So you have found omega 2 as. So what we have done is, from the given Bode plot, by considering different lines, we could find the magnitudes, unknown magnitudes, A1 and A2, and also we could find the unknown frequencies omega 1 and omega 2. So this is the procedure to solve the reverse Bode problems. Okay, so the same analogy can be used for any type of problems. All right, fine. So once you are done with the calculation of this, you can go to part B. So in part B, you are supposed to find the transfer function. But beforehand only we have found something like the nature of the transfer function, right? So transfer function nature is been already written. What you have to do is you have to just place the corresponding corner frequencies. That's all. Okay, let's do that. So let's write g of s into h of s is equal to k. K we have already found, right? That is 20 log k is equal to C1, and with that we got k as 1600. Okay, and in the denominator we know that the s square term is sitting. That's because the starting slope was minus 40 decibel. Okay, so directly you could write a square in the denominator, right? And in the numerator, we have found that there is a 0 coming into picture at omega equal to 40. So at omega equal to 40, there is a first order 0. Why at omega equal to 40 there is a first order 0? That's because at omega equal to 40, the slope changes to minus 20 decibel per decade. Earlier it was minus 40, now it is minus 20. So that means to say you have to add plus 20. So addition is considered as 0 and subtraction is considered as presence of pole. Okay. And this is the frequency. So therefore, omega c, the corner frequency, is 40 radian per second. And what we need? We need the time constant. So time constant t is nothing but 1 by 40. So 1 by 40 will be the factor which you are supposed to substitute. 0.025. So time constant is 0.025. Okay, so let's substitute. So it becomes 1 plus 0.025. Yes. Okay. So that's your 0 factor. Okay. And yeah, now we are left with the first order pole. So you observe carefully. At point C, the slope changes from minus 20 decibel per decade to minus 40 decibel per decade. So to get minus 40 decibel per decade, as I mentioned previously, you need to add negative slope. So addition of negative value means there is a pole present at this particular point. So at the C, you can say that, or at omega equal to 1000, right? Because C point corresponds to omega equal to 1000. So at omega equal to 1000, there is a first order pole. That's all. So at omega equal to 1000, there is a first order pole. Okay. So when you say first order pole, you need to find out the corner frequency as well as the time constant, right? So corner frequency is pretty straightforward. Corner frequency is 1000 itself, and that will give you the time constant t as 1 by 1000, right? So 1 by 1000 from 10 to the power minus 4. One. Second. So this is also second unit is second time constant. So let us substitute. So against first order pole, let us do the substitution. 1 plus, okay, what is T2 value? T2 value is this, okay? This is T2 and this is T1. Let's take it. So it is 1 into 10 to the power minus 3 seconds. So this is your transfer function. This is your transfer function in time constant form. Okay. Now, if you want to keep the transfer function in factored form, what you can do is you can take out the time constant outside the bracket. So you can write g of s into h of s is equal to 1600. Let me take 0.025 outside the bracket. So what do I get? 0.025 in the numerator. And in the denominator, let me take out 1 milli outside. So it is a square into 1 into 10 to the power minus 3. Okay. And the remaining factors you need to write inside the bracket. So I have s plus reciprocal of 0.025. That is 40. Right. And here I have s plus reciprocal of 1 milli. 1 milli is 1000. And then you can, little simplify. So when you simplify, you have 1600 into 0.025 divided by 1 milli. That is around 40,000, right? 40,000. So in factored form, the transfer function takes the following shape. So it is 40,000 into s plus 40 divided by s square into s plus 1000. Okay, so this is a given transfer function which we write from, which we extract from the Bode plot. Okay, so what I'll do, I will send some problems, some 2-3 problems I will send, and you try to find out the transfer function. Okay, hope you have understood this particular problem.